Good evening guys, this is Sumaiya. Welcome back to my YouTube channel. Today in this tutorial we are going to learn what is cylindrical illuminance and how to calculate the same in the DIALux evo. We'll be considering some basic examples first to understand what this is, and then we will check how to measure it in the DIALux evo. Let's get started. Cylindrical illuminance. Let's start with something very basic to understand this, like a soda can. Now imagine we want to measure how much light is falling around this can from all sides, like from all the 360-degree round, not just on the top or the bottom, or not just only on one side, but on all the sides. How is it possible? In my previous tutorials, we have seen what is horizontal, what is vertical illuminance, and what is perpendicular illuminance. But this is something different. Here we are not calculating amount of light is falling on one surface. Here we are talking about the light that is falling on the surface from all the directions. Okay. So since this is a soda can and it resembles the same of a cylinder, let's focus on this now. Cylinder is made up of vertical faces. Okay, and the light falling on this vertical surface, we know that it's a vertical illuminance. And when we take the average of all the vertical illuminance falling on this surface, that average value is our cylindrical illuminance. I hope you understood this. If not, let us go to DIALux and try to understand the same. Now in DIALux, I have placed this cylinder. You can get it in vertical cylinder, this shape. And as I told you that this cylinder is made up of faces, vertical faces. And to show you that, I have kept different colors on each surface. Okay. And when the light falls on this specific surface, it is vertical illumination. Okay. Only on this surface. Then again, this is another vertical illuminance. Again, this is another vertical illuminance. Let me show you that in wireframe view. See, this is our cylinder, and this cylinder is made of those vertical faces, right? And the light that is falling on vertical surface, we know it's called vertical illuminance. After you add up all this vertical illuminance, take the mean, or you can say the average value of it, that itself is your cylindrical illuminance. Don't worry, you don't have to individually calculate all the vertical illuminance. This is just for your understanding, because it's a lot more easy to do the cylindrical calculations in the DIALux. I showed you this so that you could understand technically what does it mean. Okay, now we understood what is cylindrical illuminance, and if we need to define it, it's actually the average value of all the vertical illuminance coming from all the sides, right? Let's consider our next example of a person. When you see this person, it may appear as a vertical plane. The face and the body seems to be a vertical plane, but we need to measure how much light is falling on this person from all the sides. Okay, why? Because the person is 3D, not a 2D, right? If it's 3D, we need to calculate how much light is falling on this person from all the directions. Hence, we will consider a cylinder, cylindrical illuminance. And we know what is cylindrical illuminance. It's the average of all the vertical illuminance from every angle around the person, like complete 360-degree. Clear? But why? Why do we have to do this cylindrical illuminance calculation? This we do to assess how well an object or a person is lit from all the sides. Let us understand this with an real-time example of a project in the DIALux evo, and we'll also see how to calculate it in the DIALux. I have considered a sample project of a small retail showroom here, and I'm going to explain why am I running the cylindrical calculations here and how to run it. Now we'll be doing the cylindrical illuminance calculation for the object where we need to calculate the light coming from all directions. Okay. Now here for the retail, we'll go object by object and see where we can use the cylindrical illuminance. Our first object is mannequin. and understand how you will be seeing this mannequin. So when you enter into this retail showroom, of course it's in the main display. We need to make sure that it is properly illuminated from the front, and of course when you go inside the showroom, okay, you might be viewing this mannequin from all the directions, right? So we need to make sure that this mannequin is lit properly, and since this is something which is viewed from all directions, we will be doing cylindrical illuminance calculation for this mannequin. Next, we have this cloth display racks, and cloth display racks, we need to make sure that it has good illuminance on this clothing display on this rack, and we have a wall here, okay, so we'll be skipping this one. We'll not be doing cylindrical illuminance. Then same for here, we'll be doing just vertical illuminance calculation here, okay. But coming for the people who are moving around the retail showroom, we need to make sure that the people are well lit, okay. There could be many reasons why we need to make sure that they are well lit. One reason, because could be there will be under CCTV surveillance, and we need to make sure they are properly lit so that they are clear in the CCTV footages. Just one observation. And people are 3D. We need to measure how much of the light is falling from all direction on the person, on the people. That's why we will do a cylindrical illuminance on this person. Okay, next we have the reception desk. On the reception desk, this is our main work area, and we will be doing horizontal calculation for this reception table. Next, we have receptionist, and receptionist is the person whom the customers see first, and this is the person which welcomes the customers in the showroom. So her facial expressions, her face should be properly lit so that the people can engage better, right? And the receptionist is 3D. We need to make sure she is properly visible from anywhere in the retail. And for that reason, here too will be doing cylindrical illuminance. Okay, in this project, we will be doing cylindrical illuminance for 3 objects. 1, the mannequin. 2, the people, customers. 3, the receptionist. Okay, now let's see how to do the cylindrical illuminance calculation in the DIALux evo. We'll go to the plan view, go to the calculation objects, and we will be selecting calculation point. Not surface, we'll be considering point. Not surface because here the light will be calculated coming from one direction, but we need to calculate how much amount of light is coming from all the directions. Okay, so we'll be considering point. Let's go object by object and place it. First, we'll start with mannequin. Place it. Name it mannequin. Positioning, I will keep it 1.6 meters. That's the height. Calculation parameters, uncheck this and click on cylindrical illuminance. That's it. Now I'll go to the other here where I need to calculate the cylindrical illuminance. Place calculation object, move it, name it as customer. Positioning, since here I will be calculating for the person who is standing, so I will position it at 1.6. okay. Calculation parameters, click on cylindrical illuminance, rest all unchecked. Next, we'll be positioning the calculation point on the receptionist. Place calculation object. You can choose the move tool to position it accurately. Name it as receptionist, and since she is sitting, I'll place it at, if you want to calculate for sitting people, you will position it at 1.2, and if you're calculating for the people who are standing, there you can calculate 1.6. Calculation parameters, uncheck this one and click on cylindrical illuminance. That's it. We have placed all the calculation points. You can see those calculation points here, here, and here. Now we'll go to the settings, keep it standards, run without objects and furniture. Whenever you want to view the results as a final output to evaluate your lux levels and uniformity, run it without objects and furniture. Why? Because objects also has shadows. Okay, and if you run calculation with objects, that shadows will also be calculated. DIALux do not differentiate between light and shadow. So that's the reason you run the calculation without objects and furniture. Here and now run. Calculation is completed and you can see the lux values here. 174 lux on the customer. On the mannequin, I'm just getting 117 lux. On the receptionist, I'm getting 147 lux. So only on the mannequin, I'm getting very less amount of lux levels. Obviously, because I haven't placed any extra lights for the mannequins. Okay, and in from front to there is no light. That's why my lux levels are very less. This is the advantage of doing the cylindrical illuminance calculation. You can check if your objects are well lit or your lighting need to be improvised. I hope you understood how to do cylindrical illuminance calculation in the DIALux. DIALux calculate your last value. As we discussed, the cylindrical illuminance is the average of all the light coming from all sides. So it will be calculating all the light coming from all the directions. It will take the average and it will show you the value, and that is the value we are getting here. I hope it's clear. Where is it commonly used? Where can we use the cylindrical illuminance? Any application where facial recognition is a criteria, is an important factor of your lighting design, there you can use your cylindrical illuminance. Like for example, if you have a video conference, okay, in video conferencing, we need to make sure that faces of the people are properly lit because it's for communication, right? And we can use it in airport application, especially at immigrations, because that's the place where facial recognition is very important, is a top priority, right? So such application you can use your cylindrical illuminance calculation. And cylindrical illuminance calculation is not just for people. Okay, it can be anywhere where you need to calculate the light coming from all the directions. Like for example, if you're working on a retail project, you have mannequins, okay, and mannequins need to be visible from anywhere in the retail showroom. Next, of course, you can use it in the museums where you need to make sure that the sculpture is properly lit. Again, the sculpture will be receiving light from all the directions and we need to make sure it's properly lit. These are few examples. You can even use this vertical illuminance calculations in your facade projects, especially on columns. So column is a structure where you need to calculate light coming from all the directions. In case if your lighting concept is such, then you can run cylindrical elements calculation there. These are few examples to help you understand why and where we can use cylindrical illuminance calculation in the lighting design. So this is it guys in this video. I hope you found this video helpful. If you did, please hit a thumbs up, subscribe to my channel and stay tuned to explore more in DIALux with me. Thank you.